Hey everyone, I just want to go over some basic terms and things that we should know in preparation for this week. And basically, they're the theorems in geometry. First being vertical angle theorem. All semester long, I've been saying if we have two lines and they create an X, right, any way how it looks, you're going to have vertical angles. And we all know that vertical angles are the same. So this angle over here, same as this angle over here, this one and this one are the same. Well, I've just been saying that, but it's called the vertical angle theorem. So any two lines cross, a pair of vertical angles, and vertical angles are the same. Okay, transitive property of congruence. Transitive property, two shapes are congruent to a third. So basically, let me try to show you what that means. If angle 1 and angle 4 are the same, and angle 4 and angle 5 are the same, then angle 1 and angle 5 are the same. Basically, if 1 equals 2, and 2, if A equals B and B equals C, then A equals C as well. So just passing on your trait to someone else. So hope that makes sense. Okay, corresponding angles postulate. Basically, we've done this a zillion times. We just haven't called it a postulate or a theorem. So two lines here, this one are parallel, and we have this transversal cutting through them. Then all the angles up here are the same as the angles down here. So 1 and 5 are corresponding angles. 2 and 6 corresponding. 3 and 7, 4 and 8 corresponding. So 1, 2, 3, 4 corresponds with 5, 6, 7, 8 respectively. All right. Alternate exterior angles theorem. So if we look in here, the angles inside or in between the parallel lines, those are all interior angles. So 3, 4, 5, 6 interior angles. The angles on the outside, right, of the parallel lines, 1, 2, 7, 8, those are exterior angles. So alternate exterior are angles that are exterior on the outside of 1, 2, 7, 8, but on alternate sides of the transversal. So 1 and 8 are alternate exterior angles, and they are the same angle. 2 and 7 are the same. With that same respect, we have the alternate interior angles theorem, which states that 3, 6, 4, and 5, those are also the same. So anytime you have parallel lines like this one and this one with the transversal, you're going to have corresponding angles. 1, 2, 3, 4 is the same angles as 5, 6, 7, 8. And alternate exterior like 1 and 8, 2 and 7 are the same angle. Alternate interior, 3, 6, and 4, 5 are the same. Also, we have that in reverse as well. If you have two lines with the transversal and these alternate interior angles happen to be the same, then these two lines must be parallel. That is what we call the converse of corresponding and converse of alternate exterior. Notice I didn't write converse of alternate interior. It's becoming redundant now. But basically, if these are parallel and you have a transversal, then alternate exterior corresponding are all the same, and vice versa. If alternate interior angles are the same, that only happens if these two lines are parallel. You can't have one without the other. They go hand in hand. And lastly, we have the Hinge theorem. Hinge theorem is interesting. So here I'm going to make a triangle, and I have this length side, and I'm going to just create a triangle. Boom. Now, what the Hinge theorem says is as I increase this angle over here, the length of my third side, and as you can see, this is my third side. Right now, I have a small angle, and this is 4 inches. But if I increase this angle, notice what happens. Now I'm at 10 inches. And if I keep going, 13 and 15. So the bigger this angle is, the bigger the third side has to be. So if I'm comparing two triangles and they both have two sides that are equal, the third side is going to be determined by this angle. So hopefully that Hinge theorem explanation works. Any questions, feel free to respond to this. By the way, in any given triangle, let's just say I create a triangle with a 15 inside, 10.5 inside, and 9-ish inside. Well, let's create a triangle here. We know that the ruler is the longest side, so the angle that opens up to the longest side is going to be the biggest angle. Now I have an angle here, and I have an angle here. Let me move this camera. Now this angle opens up to this straw, which is the medium side, so he's the middle angle. The angle over here opens up to the green straw, which is the shortest side, so he's going to be the smallest angle. So the smallest angle, right, which is this one here, opens up to the shortest length, and the largest angle up here opens up to the largest length. It kind of makes sense. Anytime you have an obtuse triangle, right, then the obtuse angle is going to open up to the longest side, as is the case over here. Hope that helps.